So, hello everyone. Today we are going to discuss about symmetric and asymmetric wave functions of hydrogen molecule. So, before we are going into this topic, let me review the what we have learned in the previous chapter, in previous sessions. So, the first session. So basically, we have a two particles, two kind of particles. One is boson particles, one is fermions. Okay, in the quantum mechanics. Okay, so if we consider the classical mechanics, so all identical in classical mechanics, the identical particles are in no, identical particles are deterministic particles. Means, so let us assume one particle is in the state 1, the label it as particle 1, and take another particle. Okay, uh, it is in the state 2, label it as label it as 2. Okay, here classical particles is nothing but carom coins, anything, bullets, stones, whatever. Okay, so when the first particle is in the first state, second particle is in the second state, respectively. So when these particles made to collide, then we can predict that the its trajectory, and the where the then we can predict the state of the first particle and second particle after the collision, right? So whereas in the quantum mechanics, when the two wave wave packets of an electron, it means electrons are identical to each other, but electrons are not identical to the protons. Okay, so when these electrons made to collide, okay, then we cannot predict we cannot trace out the trajectory of the electron. We can tell the first electron will be in the some 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 region. Means we can say the probabilistic probabil, probabilistic interpretation of it. We can interpret the probability of the finding of the electron in some region between this region. We cannot say the exact the electron will be in the exact position. We cannot say exact position of the electron. We can say the interpretation of probability of finding of electron between the region some x1 to x2. Okay, in quantum mechanics. So every in quantum mechanics, there are two kind of particles. One is boson particles, one is fermion particles. So the boson particles have corresponding the wave nature is symmetric wave nature, wave functions, and fermions having the corresponding anti-symmetric wave functions. Okay, so let us talk about the symmetric and asymmetric wave functions of the hydrogen atom today. So basically, if we observe this the diagram, A and B are the atom. The hydrogen molecule consists of two atoms. Hydrogen atom consists of two atoms. So one is so A is the uh, hydrogen of the hydrogen atom. Have In hydrogen we have a nucleus and electron and nucleus, right? In an atom uh, consists of electron and nucleus. So the a hydrogen molecule consists of two hydrogen atoms. If consist of two hydrogen molecules A and B, and electrons 1 and 2. Okay, this is the first electron. This electron is labeled as marked as 1. This electron is marked as 2. This is the nuclei A, and this is the nuclei B. So in hydrogen molecule we have two hydrogen atoms. In each atom consists of one nucleus, one electron. Okay, Understood? So each electron consists of a the e- electrons are revolve around the nucleus. Okay. Uh, so the electron orbit about about its about its spin. Every electron have a positive spin and negative spin. Okay. If these two electrons have the positive spins, means plus off and plus off, so these two electrons get repel each other. If one electron is positive, one electron is negative, then these electrons are attract each other. Okay. So distance between these the two electrons is r12. The two atoms repel each other if the spin of the electrons are parallel. Okay. And attract each other if the spin of the two electrons are anti-parallel. Okay. Now write the Schrodinger equation for the hydrogen molecule. Now, now write the uh, Schrodinger equation for the hydrogen molecule. So here del 1 represents the dou by dou x1 x cap plus dou by dou y1 y1 cap plus dou z1 into z1 cap. Okay. Z2 represents the dou divided by dou x2 cap plus dou divided by dou y2 cap plus dou divided by dou z2 cap. Okay. So I'm not using any pen to explain this. Please be clear. Listen carefully. Okay. What I'm saying. Okay. So here E is the total energy of the hydrogen molecule. Here E is the total energy of the hydrogen molecule. V1 is the potential of the first electron. V2 is the potential of the second electron. So here E square divided by 4 pi epsilon naught R1 R2 is the electric potential between these two electrons. E square divided by 4 pi epsilon naught R R12. So R12 is the electric potential between the two electrons. Okay. Understood? So here he is the energy of the hydrogen molecule. If we neglect the term E square divided by R, if we neglect the electric potential between the two electrons, then the potential of hydrogen total energy of the two electrons will be EA plus EB. Then the solution of the equation 1 is given by psi is equal to psi A of 1, psi B of 2. So as we discussed in the symmetric and asymmetric wave function session, so the first electron having one wave packet, the second wave function, the second electron having the one wave packet. Okay. when when these two wave function collide, okay, that then we can write the combined wave function. So as I discussed in the symmetric and asymmetric wave function, so this first electron having the having corresponding wave packet, this electron having the corresponding the second wave packet. When these two wave function collides, then we can write the resultant wave as the combined wave function of the two wave function. Combine We can combine the two wave functions. when these two electrons the made to when collide, then we can write the combined wave function of the two wave functions of the electrons as psi is equal to psi a of 1 and psi b of 2. So these quantum particles are indeterministic particles. So first we assume that first electron number 1 is in the nuclei A, and while electron 2 is in the nuclei 2, nuclei B. But due to the indeterministic of two electron, indeterministic means we cannot clearly enough to recognize the where the particle is. Okay, the falling solution is also possible. Then falling solution is also possible. So second electron may exist in the nuclei A, first electron may exist in the nuclei B. Then the combined wave function after the collision, then we can write the combined the wave functions of the two electrons. Okay, now so after the made of these two electrons made to collide, then we can write the combined wave function of the two electrons. So then psi is equal to psi a of 2 psi b of 1. So if we want to find the probabilistic density, means where the if we want to find the where the particle is, then what we have to do, we have to do the we have to take the probabilistic distribution, right? The probability of finding of electron some in the between the regions. Okay, then this psi and this psi will be equal. Okay, then now we can construct the symmetric and asymmetric wave functions for the hydrogen molecule. This the psi suffix s is equal to psi a of 1 psi b of 2 plus psi a of 2 plus psi b of 1. This is the symmetric wave function. Psi a is equal to psi a of 1 psi b of 2 minus psi a of 2 psi b of 1. This is the asymmetric wave function. Okay, now we shall consider spin of the electron. First we are neglecting the spin of the electron, and the Schrodinger equation of the Schrodinger equation, the Schrodinger wave function is given by, first we neglected the spin of the electron. Now we shall consider spin of the electron. Okay, we know that each electron has a spin. సో ప్రతి ఎలక్ట్రాన్కి ఒక స్పిన్ ఉంటుంది. ఓకే, పాజిటివ్ స్పిన్ ఆర్ నెగిటివ్ స్పిన్. ఓకే, ఇఫ్ టూ స్పిన్స్ దెన్ కంబైన్ టు గివ్ ఏ రిజల్టెంట్ స్పిన్. ఒక టూ స్పిన్స్ని మనం కలిపితే కనుక మనకు ఒక రిజల్టెంట్ స్పిన్ వస్తుంది. ఒకవేళ టూ స్పిన్స్ పాజిటివ్ స్పిన్స్ అనేవి ప్లస్ ఆఫ్ ఎంత 1. సో if we combine the two spins, we will get the spin is equal to 1. Then when the two spins are in the same directions, the resultant spin is 1. The two spins are in opposite direction, the resultant spin is 0. So denoting the positive spin as alpha and negative spin as the beta, we have the following four spin functions. But make a positive negative positive negative పాజిటివ్ నెగిటివ్. సో మన కాంబినేషన్స్ ఎన్ని వస్తాయి? సో ప్లస్ మైనస్ ఉన్నప్పుడు మనకు పాసిబిలిటీస్ ఎన్ని వస్తాయి? 4 వస్తాయి. ప్లస్ 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 మైనస్ మైనస్ ప్లస్ మైనస్ మైనస్. ఓకే, లైక్ దట్. ఇది 1 ఇక్కడ బ్రాకెట్లో 1 రిప్రజెంట్స్ ఏంటంటే ఫస్ట్ పార్టికల్, బ్రాకెట్లో 2 రిప్రజెంట్స్ ద సెకండ్ పార్టికల్, ఆల్ఫా రిప్రజెంట్స్ ది పాజిటివ్ స్పిన్. సో ఫస్ట్ ఎలక్ట్రాన్కి పాజిటివ్ స్పిన్, సెకండ్ ఎలక్ట్రాన్కి పాజిటివ్ స్పిన్. ఫస్ట్ ఎలక్ట్రాన్కి పాజిటివ్ స్పిన్, సెకండ్ ఎలక్ట్రాన్కి పాజిటివ్ స్పిన్. ఓకే, ఇప్పుడు ఫస్ట్ ఎలక్ట్రాన్కి నెగిటివ్ స్పిన్, సెకండ్ ఎలక్ట్రాన్కి నెగిటివ్ స్పిన్, ఫస్ట్ ఎలక్ట్రాన్కి నెగిటివ్ స్పిన్, సెకండ్ ఎలక్ట్రాన్కి నెగిటివ్ స్పిన్. ఫస్ట్ ఫస్ట్ పార్టికల్కి పాజిటివ్ స్పిన్, నెక్స్ట్ ఎలక్ట్రాన్కి నెగిటివ్ స్పిన్. ఫస్ట్ చూడండి, ఇక్కడ ఫస్ట్ ఎలక్ట్రాన్కి, ఫస్ట్ ఎలక్ట్రాన్కి ఇక్కడ పాజిటివ్ స్పిన్ ఉంది. ఇక్కడ సెకండ్ ఎలక్ట్రాన్కి నెగిటివ్ స్పిన్ ఉంది. ఓకే, ఇక్కడ ఇక్కడ చూసుకుంటే, ఇది చూస్తే ఫస్ట్ ఎలక్ట్రాన్కి నెగిటివ్ స్పిన్, ఫస్ట్ ఎలక్ట్రాన్కి సెకండ్ ఎలక్ట్రాన్కి పాజిటివ్ స్పిన్, ఫస్ట్ ఎలక్ట్రాన్కి నెగిటివ్ స్పిన్, సెకండ్ ఎలక్ట్రాన్కి పాజిటివ్ స్పిన్. ఓకే, so due to the indistinguishable of electrons, the following four spin functions are possible. సో ఇండిస్టింగ్విషబుల్ ఆఫ్ ఎలక్ట్రాన్స్ వల్ల సో మనకి ఫోర్ స్పిన్ ఫంక్షన్స్ అనేవి పాసిబుల్ అవుతాయి. సో ఆల్ఫా 1 ఆల్ఫా 2 ఈజ్ ద asymmetric wave function, beta 1 beta 2, beta of 1 and beta of 2 are symmetric wave functions. So if we combine alpha 1 beta of 2 plus beta of 1 and alpha of 2 is also symmetric wave function. This is the last one will become the asymmetric wave function. Okay, so including the spin, the following functions also possible. Okay, so including the spin, the possible wave functions also possible. So if we multiply the psi a of 1 into psi b of 2 plus psi a of 2 into psi b of 1 into this all the matrix, a of 1 into b of 2, so like that. And so we know that the total wave function must be antisymmetric in exchange of coordinates of every pair of the elements, and the possible wave functions are given below. Okay, so you got only the one wave function, that's why it's a singlet. You got three wave functions, that's why it is a triplet. Okay, thank you. So today's class is completed.